Hello everyone. This is still in the limits lesson, right? Okay, limits of functions. This one's still in the exercise or chapter of the properties of limits. Exercise number 14.2. Okay, so this is the one section which is important. Also, everyone have to know how to do is the greatest integer functions. So what the meanings of this? See this. The greatest integer function we like in this one, f of x. This one should be like small x, okay, not that big. Small x. Say f of x equal to function f of x equal to x equal to the greatest integer function. So, like for example, if we before when we know linear equation like y equal to ax plus b, so we know the linear function, right? So we can write like this: if a y equal to x squared plus b x plus c, like this. So we know this is a parabola or quadratic equations. At the same time, if we write in this pattern, so if you see this one represent what the greatest integer function right away. So this is a function, and we represent by this side like this bracket like this one. So if you see this shape means the greatest integer function. What the meaning is? The meaning is defined to be the greatest integer that is less than or equal to a given number. So take a look at our example here. Okay, see the example for f of x equal to x negative the greatest integer plus the negative greatest integer x, and they want to find the limit f of limit h of x when x approaches to, if this limit is exists, this limit exists whether or not. Okay, now with how to do. So in this case, we have to do by using the two-sided limit. Why I know? Because you see that here, this one, the key points right here. This one, x approaches to, right? So on the top up to the right corner, no plus, no minus sign. So that means we have to show both sides. We have to work on the both sides, mean from the left hand and the right hand limit. Okay. So in this case, we have to do both. Then we're gonna use the two-sided limit to find out this limit exists whether or not. Does it exist or not? Okay. So now we start to do. I will write it down as. So first of all, we have to take the limit both sides from this equation first. So we write down, take the limit both sides. Okay. So become limit h of x when x approaches to equal to limit. Okay, then I write the whole thing bracket minus the great integer x. Just copy it down, that's all. And close it, and then x approaches to. Okay, after we take the limit both sides, then we find first one we can do the highlight limit first, right? So I can write it down here, say limit h of x when x approaches to. We do the first case first, okay? So this one equal to limit. Just slide the whole thing down here. Copy it down. And then x, then now this one, x approaches to plus, because we're gonna do from the right hand side, okay? So we're gonna do from the right hand side. So x approaches to, okay? And then after this one, we consider, you say, I like one linear line, I mean the number line, okay? Maybe say 0 right here. And because 2 plus, right? So 1, 2, 2 maybe around here. So we have to read the when the x, when x approaches the most close as possible to 2. Okay, but this one is a plus sign. You see that? Everyone see this. This is a key point right here. Okay, so we lead from the right because plus, so you lead from the right hand. The most close as possible is, maybe I try like this one, right? So I pick 2.0000001 like this. Even you can make 0.0000000 and 1, okay? But then we just approximate this one, 0.00001. So 5 digits after decimal. Okay, so when you have this is the x, right? Approach to the right hand side, that means 2 plus here. Then you replace, after this one, you replace the value of x in this limit. But when you replace the value of x here, the limit writing is gone, right? We don't need to write down. So from this one, we just write in this way. Replace this, become 2.0000001. Still like in the greater integer pattern, okay? So then minus this one, oh sorry, it should be, we replace it. So this one gonna be 2.00001, the same thing, and then close it. After this, we can read according the greater integer definition. We have to read the less than, right? So from this one, we read the first one, 2.0001 here, the greater integer. So you see from here, the next one, the integer difference less than 2.0001. The integer the less than 2.001 is what? Is the 2, correct? So we write this one as a negative, so from this one negative, okay? So we write this one as a 2. Okay, so then plus, right? Maybe you can write like this step by step. If you know, we may not write too many bracket like this. So this one can be, I can write it down like a big bracket like this way. And then 2 is inside. Okay, this bracket means this one, right? And minus, this minus, and this great integer after we read is this one is equal to 2. Then plus, okay? So now we read this one, negative 2.0001. So negative 0.001, it be on the number line, I write down here, 2.00001. So the integer that's less than, the number integer which is less than negative 2.0001 is what? Should be what? Negative 3, correct? Right? So the next integer less than negative 2.001. So it should be, this one should be negative 3. So you write negative 3 here. And then close the bracket. This close, this one bracket, close here, okay? Mean these two bracket. So again, keep in mind, after you read the great integer in the integer number now here in this one you write the bracket, no more writing in this shape, okay? Because after you read this one, no more to write down, okay? So it's gone. So you write bracket, general bracket you have. So that means when you simplify, gonna be what? Minus 2, minus 3, right? So equal to negative 5. So we get the value of limit one from the right hand limit equal to negative 5. Now we go to the left hand limit. Okay, if I have this one, I still like the same way, okay? Or this one should be like this one, I have open bracket, and then this one greater integer pattern. So plus like this. Just copy this one down, but right now x we're gonna do from the left hand limit, correct? So this one gonna be minus. Everyone see the key point? This one is the plus, right? This is a right hand limit, and this one is the left hand limit. This is the heart of limit. Don't forget, you must write down every time. You must, okay? So then this one, then we have this one. After this one, again, we're gonna do this one, right? Now I can draw one, maybe one more number line here. Right now we want to read from the left hand, okay? This is again this 0, right? And this one maybe 2. Then to approaches to from the left hand side, correct? So have to be approach to here, correct? So left, right? So this is minus negative on the top, so from the left. So the really close or possible really close to 2, it's gonna be what, 1.99999, right? Can be like a point 1.999999999 whatever you want. But now I use only 5 digit 1 2 3 4 5. Then this one have to use after decimal have to be 5 digits also, correct? So be 1 2 3 4 5. So 5 digits as well as like a beginning we use. So in this case, I will replace this one x equal to this one in the pattern of the, just say replace in here the greater integer. So I have, when you replace x, don't forget limit, right? Limit of writing the word here is gone. So we have this one open bracket mean this one, okay, and then minus. So I replace this one with the, you see the integer which is less than 1.9999, the integer next one less than this one is what? Should be 1, correct? So we have like 1 there. And then plus, then you read this one. Or maybe I replace first better, correct? You won't be confused. I replace it better before we read. So I replace it first. So become 1.99999. Okay. But if you replace this one still in the box, still in the because we haven't read it out. So then plus, and this one going to be minus 1.99999 and close. After this, you can, now we read. Now we can read now, okay? So then this one, the integer less than 1.9999 is what? Should be 1, correct? So this one gonna be, this one open bracket 1, and this one gonna be 1. Okay, this one when you read it up, here gonna be 1. Then this one is what? Plus. Then you see if negative 1.9999, it's gonna be this side, correct? For example, this one negative 2. So negative 1.99 is somewhere here, correct? Somewhere here, right? This one gonna be negative 1.99999. Okay. So the integer which is less than negative 1.9999 is what? The next one is what? Negative 2, right? So you like represent this one, right? Become open now, because after you read, you open now, become not in the great integer sign anymore, okay? So you're gonna have minus negative, just say negative 2 and then close. So after that you can simplify. This one become minus 1 minus 2 and then sum it up, negative 3, I mean negative 1, right? Negative 2, and then you sum it up, become negative 3, negative 1 plus negative 2. Okay, so then after this one, you can see we have this one, right? So we got the limit of the function f of h of x, which is from the left hand limit is equal to negative 3. So when you see this one, when you have this, from this one, from the right hand limit and the left hand limit are not equal, right? So then you can conclusion this question is does not limit. That means this one, the whole thing here. So final, you like at the final for me at the bottom, say limit h of x when x approaches to does not exist. Okay, because the limit when you prove here they are not equal. Okay, so I think that's all for this lesson, the greater integer function, and then you're gonna practice some question. I give you allow 4 to 5 questions, okay, and then you check in GC. See you next class. Bye bye.